So now we look at another exam question, and this one comes from 2019, paper 1, question number 23. So the question is, the diagram below is the speed time graph of a car. The car starts from rest and accelerates uniformly at 2 meters per second squared for t seconds until it reaches a speed of 16 meters per second. We have a full stop there. Then the next sentence says, it then travels at 16 meters per second for 40 seconds, after which it comes to rest in a further 10 seconds. Now, this is the diagram we have here. This is the diagram we have been given, which is for speed time graph, So now we find the questions are saying, find the value of t. So finding the value of t, we are going to use the method for acceleration, because this is acceleration where t is found. Remember, the x-axis is always for time, and the y-axis is always for speed or velocity. So we are going to say acceleration is equal to final minus initial over time taken. Now, what is our acceleration? Our acceleration has been given as 2. So I'm going to say 2 meters per second. Of course, I won't write meters per second. I'll just move on. Our velocity final is 16 minus our initial, which is 0, over time taken, which is this time here, is t. So now we're going to cross multiply there. So we're going to have t, 2t is equal to 16 minus 0. It is the same 16. Then you say divided by 2, and this other side by 2. So we are going to have t is equal to, 8. So we are going to have 80 seconds, because t is time. We are going to find our t is 8 seconds. The next question is question number B. Question number B is under distance. So we are trying to find the distance traveled in the last 50 seconds. Now, what do they mean by the last 50 seconds? Maybe before I go any further, may you please copy this, and please pause your video and copy it, because I'm now going to question number B. So now we move. We are told that we have known that the value of t here, where there was t, now we replace it with 8 seconds. Now we are told that if you read this information, told that the car starts from rest and accelerates uniformly at 2 meters per second for t seconds until it reaches a speed of 16 meters per second. So meaning it reaches 16 meters per second per second. It then travels at 16 meters, meaning constant speed, for 40 seconds. Meaning from 80 up to this point here, it is supposed to be 40. So meaning I can't write 40 here, it won't make sense, because from here up to here is 40. So meaning I need to add 8 plus 40. Meaning I have 48 this point here. So for 40 seconds, after which it decelerates. Okay? Decelerates to the further 10 seconds. Meaning now I have 48 plus 10, where I have 58 seconds. So these are seconds. Okay, I hope you are able to see the way I've come up with these things here. I hope you have understood on how I have come up with the time. This means that our t is 8. Our t is 8. Okay, I will still use this one. I like labbing the original question. Now, question number D says the speed of the car. Question number B, the distance traveled in the last 50 seconds. So to find the distance, I'll use the formula for trapezium. We said distance is found by finding the area of the everything. So we'll say A plus B and height. So we're going to have A is equal to 1 over 2. My A is from here up to here. My B is from here up to here, meaning this side here. This one will be my B. So we are going to have my A is from here up to here, which will be 40 plus. Because 48 minus 8 is 40 plus 58 minus 0. Oh, not up to 0, but up to 30. Up to 8. Because the question is saying for the last 50. Because from 8 to 58 is 50 seconds. Meaning here our 50, then multiplied by the height from here up to here, which is the same as from here up to here, the same as from here up to there, which is 16. So now we are going to have area is equal to 1 over 2 multiplied by 90 multiplied by 16. So I'm going to say this into this, it goes 8. So I'm going to have A is equal to 90 multiplied by 8. A is equal to, what is 90 multiplied by 8? What is 90 multiplied by 8? The answer will be 720 meters. So therefore the distance covered, the distance in the last 50 seconds is 720 meters. So this is what we have. Now we go to the next question. We go to the next question. Please copy this one before we go to the next question. Please copy that one before we go to the next question. So for C, the speed of the car when T is 53. So I have gotten this part. The last part here, it is the one which I have gotten, which I have written there. Why have I picked this one? Because it is the one which has 53. This is 48. This one is 58. Meaning 53 is in between 48 and also 58. So I will say my 53 will be here. This is an assumption. My 53 will be there, or 53. So now, what will be the speed? So we are going to use, as usual, we use the formula for acceleration, which is final velocity minus initial velocity over time taken. Our interest is to find V. We have looked at this and do this from the previous videos. We are saying V is equal to AT plus U. Now, what is our A? Our A is the acceleration, which is the deceleration. So our A will be A is equal to our final velocity. This is 0 here, mind you. It will be 0 minus 16 over the time taken is from here up to here, which is 10. So our acceleration will be negative 16 over 10, which is negative 1.6 meters per second squared. This is our acceleration, but this is not our final answer. So what do we do now? Having known the final answer, now we'll say our V is equal to negative 1.6 multiplied by, what is the time taken? From 48 to 53. What is the time taken from 48 to 53? The answer is 5 Then I'm going to say plus. What is the initial velocity? The initial is 16. Our initial will be 16. So our final answer will be this one times negative 1.6 multiplied by 5. The answer is negative 8. So negative 8 plus 16. So our V will be 8. Our A, it will be 8 meters per second. So the speed for when the time is 53 is 8 meters per second. Otherwise, we end here. I will still send some sample exam questions as part of your task or your assessment. Please go through them, work them out. Otherwise, thank you so much.